In the cold and dark darkness of the room, an invisible hand seemed to reach out to cut the strings of fate. Invisibly, he steered a great stone through the infinite darkness, toward a tiny blue dot that swirled across the expanse. This is no ordinary sand. This is a massive asteroid, big enough to change the course of history forever. For years, scientists have been warning about dangerous things in the world, and now that danger has a name, Apis. Named after the ancient Egyptian god of chaos, this 350-meter-tall giant is bearing the brunt of the destruction that follows, and is crashing right into the ground. When the census begins, people face an unprecedented challenge. Can we avoid the disaster, or will Apophis fulfill its dark promise and become a sign of disaster? The competition has started with the season and the chances cannot be increased. The year is 2029. Scientists all over the world are caught in a mad race against time. They have discovered a potential disaster. A 350-meter-wide asteroid, Apophis, is about to crash into Earth. Named after the Egyptian god of chaos, Apophis is the embodiment of destruction. With only 5 years to go until next year approaches, the world is holding its breath. Could this asteroid be the end of the world as we know it, or is it still hoping to destroy this planet? The answer lies in a web of scientific calculations, political decisions and human capacity to act in the face of unimaginable problems. It was just one day in June 2004 and astronomers Roy Tucker, David Tulin and Fabrizio Bernardi made a discovery that shook the foundation of our understanding of planetary threats. Working hard at the Kite Peak National Observatory in Arizona, they have discovered a new object in the night sky, an S-type asteroid with a diameter of 350 meters. At first it looked like just another space rock, one of the many bodies that peacefully inhabit our Sun. When they followed its path, the astronomers realized that this asteroid, which was later called Apophis, was different. It went straight to the ground. The name of the asteroid was chosen carefully. In ancient Egyptian mythology, Apophis was a god associated with darkness and chaos, an apt name for a celestial body capable of endless destruction. The first calculations revealed an alarming news: Apophis will come dangerously close to the Earth on April 13, 2029. It is expected that a large object will pass close to our planet, causing shock waves to the scientific community. As data continues to flow in, experts try to assess the damage Apophis could do if it hits Earth. The composition of the asteroid, silicate rock mixed with iron and nickel, means it is very dense and capable of releasing a large amount of energy on impact. The estimates are astonishing. Apophis could have released the equivalent of 900 megatons of TNT upon impact. To illustrate this, the largest nuclear explosion ever detonated by man, the Tsar Bomba, produced only 50 megatons of TNT. The consequences can be dire. If Apophis hits the ground, it will create a dead zone with a radius of 250 kilometers, and everything in its path will be paralyzed. Those in this area have no chance of survival. This eruption can cause massive fires, earthquakes, and possibly volcanic eruptions. Outside of the immediate deployment zone, shock waves and wind disturbances can still cause significant damage, but the risk of survival increases. If an asteroid hits the ocean, it probably won't get any worse. This collision produces a huge wave with waves over 100 meters high. Coastal cities and towns around the world are wreaked havoc on large parts of the country when waves hit the oceans. For a while, the worst seems inevitable. The first calculations in December 2004 suggested a 2.7% chance of an effect, or about 1 in 37. This year's figure may seem small, but considering the results, it's a lot. Just a lot of anxiety. However, as more data is collected and analyzed, the probability of a collision in 2029 decreases. By late 2004, experts were confident that Apophis would not make landfall anytime soon. But this peace is short-lived. It turned out that the Apophis was not a single guest. Its orbit will be close to Earth again in 2036 and 2068. Each time, the asteroid will pass within a hair's breadth of our planet, almost visible to the naked eye. The possibility that one of these future collisions could lead to a collision remains a concern. In the year 2020, when the world is beginning to calm down about the threat from the Apophis, a new discovery takes hold. Observations made with the Subaru telescope on Mauna Kea in Hawaii showed that Apophis was not where expected. This asteroid deviates from its orbit by 170 meters per year. This small fashion change has huge consequences. The culprit was the Yarkovsky effect, a phenomenon caused by the uneven heating of the asteroid's surface. As Apophis rotates, different sides of the asteroid absorb heat at different rates, creating a small but steady vortex that moves around its orbit. This effect, previously thought to be small, now increases the probability of a collision in 2068. This discovery caused shock waves in the scientific community. Now, the Apophis threat is back on the table, and experts are beginning to reevaluate the risk. But just a few months later, NASA announced that new observations had also ruled out the possibility of a collision in 2068. It appears that disaster has been averted again. Although much of the public's attention was focused on negative energy, researchers saw Apophis as a unique research opportunity. Near-Earth asteroids of this size approach our planet only once every century. The Apophis approach provides a rare opportunity to study something like this up close, opening up new perspectives on the nature of asteroids and the threats they pose. A group from the University of Würzburg in Germany started developing 3 different programs to study the Apophis. These missions, known as the NOLY project, aimed to collect significant data on the asteroid structure, orbit and interactions with other celestial bodies. Understanding these factors is key to developing strategies to defend against future asteroids. One of the proposed projects was to send a small satellite to observe Apophis for 2 months while it was near the Earth. The satellite captures images and measurements, revealing the asteroid's characteristics. Another concept, known as Ramses, proposed a larger satellite equipped with more instruments to study Apophis in more detail. A third approach involved a single-flight mission, which was less expensive but required less data. As scientists work to understand Apophis, NASA and other space agencies around the world wrestle with a bigger question: what can be done to prevent a negative impact? The concept of planetary defense, protecting Earth from asteroids and comets, has long been debated, but the Apophis threat has brought it into focus. In recent years, NASA has conducted several asteroid alert exercises that simulate the detection of a dangerous object heading for Earth. The exercises, which have been held every 2 years since 2016, are designed to test the world's radiation response to such problems. The most recent exercise, which took place in 2020, presented participants with a scenario similar to Apophis's greatest threat, a large asteroid that was discovered just 14 years before it hit Earth, and a 72% chance of hitting Earth. The results of the exercise were disappointing. While the exercises helped to raise awareness of the asteroid threat and identify some major challenges, they also revealed some important gaps in our preparations. A major problem is the lack of a clear plan for responding to an impending impact. Although there is a UN planning commission known as the Space Mission Planning Advisory Group, SMPAG, its role in the international context remains unclear. In addition, the work showed that it is very difficult to maintain focus on asteroid protection for a long time, such as 14 years before a suspected impact. Political changes, budget differences and other international events can easily cancel jobs. Despite the challenges, NASA and other space agencies continue to explore potential strategies for dealing with asteroid impacts. One of the most effective ways is to use accelerators, spacecraft designed to collide with an asteroid at high speed and change its course. This technique has been successfully tested on a small scale, but its effectiveness on a large asteroid like Apophis has yet to be tested. Another option is to use nuclear explosives to deflect or destroy an incoming asteroid. Although this method may be more effective, it also has significant risks, including the creation of small, but still dangerous, fragments. In addition, international treaties prohibit the use of nuclear weapons in space, as this option is legally and politically difficult, although researchers are still researching these and other strategies, time is of the essence. The approach to Apis in 2029, with its subsequent closures in 2036 and 2068, is a reminder of the dangers facing the world. Although the threat of a collision has been eliminated, the need for a planetary defense system is growing. In the event of an emergency, some experts said that people should also be prepared to avoid the consequences. This includes developing disaster response and disaster recovery plans. For example, governments can implement strategies for mass evacuation, emergency medical treatment and post-victim reconstruction. The need for international cooperation to deal with the asteroid threat is also recognized. No country has the resources or expertise to meet this challenge. Therefore, international cooperation in the development and implementation of planetary protection measures is essential. Public awareness and education is an important part of protecting the planet. The public needs to understand the nature of an asteroid threat, the consequences of an impact, and measures that can be taken to reduce the risk. By raising awareness, scientists and policymakers can build support for the necessary investments in planetary defense and ensure that people are prepared to act in the event of an emergency. NASA has taken steps to improve public awareness through initiatives like the Planetary Defense Coordination Office, PDCO, which monitors near-Earth objects and provides information to the public. The agency also works with international partners to share data and coordinate efforts to track and study potentially hazardous asteroids. Looking ahead, one of the most important steps in improving planetary defense is enhancing our ability to detect and track asteroids. NASA is currently developing the Near-Earth Object Surveyor, a space telescope designed to search for new near-Earth asteroids. Scheduled to launch in 2028, the telescope will greatly enhance our ability to detect and monitor dangerous objects. In addition to the NEO plan, other projects are underway to improve asteroid detection and tracking. The European Space Agency (ESA) operates the Hera mission, which studies the impact of kinetic impact on asteroids and provides important data for future mitigation efforts. Currently, private companies and research institutions are exploring new technologies to detect asteroids, including ground-based telescopes and radar systems. As the wrath of Apophis approaches, the people are scattered. Advances in asteroid detection, tracking and impact are promising, but not enough to guarantee our safety. The Apis approach in 2029 will be a major test of our ability to protect ourselves from global threats. In the years to come, the lessons learned from Apis will shape the future of planetary defense. Scientists and engineers are constantly refining their techniques and developing new ways to detect and block asteroids. Governments must strengthen international cooperation and ensure that the world is prepared to respond to potential impacts. And people can play an important role in supporting efforts to protect our planet from the dangers of space. Looking ahead, one thing is certain: the threat posed by asteroids like Apis is real, and the risk is too great to ignore. But with continued vigilance, innovation and cooperation, humans can rise to the challenge and turn the tide against the forces of chaos, and ensure that our world is safe for generations to come. The future. In the end, the story of Apophis may not be a story of destruction, but a story of survival. The asteroid has already acted as a catalyst for change, sparking advances in science, technology and international cooperation. Its approach in 2029 will change our understanding of the universe and our place in it. As humans continue to explore space, the lessons of Apis will guide us in protecting our planet. Whether through the development of new technologies, the strengthening of international relations or general knowledge, Apis' legacy is one of courage and hope. The countdown has begun and the race to defend the field continues. But with wisdom, understanding and commitment to the future, we can ensure that Apophis' story is not a loss, but a victory.